Hello everyone, welcome to this video on normal distribution part 7. We have been seeing about the over-under type of problem where the mean and standard deviation are unknown to us. So using the given percentage of the data which is available, we will be able to estimate the value of Z, using which the unknown quantity mean and standard deviations can be estimated for. We will move on to the third type of problem over here. The problem goes like this. In a class of students, the height of the student is normally distributed, and we have 6% of them to have height below 60 inches and 39% of them to have height between 60 to 70 inches. We have been asked to find the mean of the data and standard deviation of the data. First things to observe, the data is going to be normally distributed. So normal distribution has to be applied for this problem. The second data is that we have been given in terms of percentage. So it is going to be the second category of problems under the normal distribution curve. So to estimate these values, which is unknown for us, namely mu, which is denoted as mean, and sigma, that is denoted as standard deviation, we will draw the reference normal distribution curve for our identification. It is going to be a bell-shaped curve. Normal distribution curve is a bell-shaped curve. Since we have been given in terms of percentage, the left hand side represents the 0% marks, and as the class gets covered entirely, we will be covering the entire of 100% of the data over here. Let us fix the center line for our reference. So this is going to be the center line, which may refer to 50% mark. Now the first data says that 6% of them have height below 60 inches. We need to keep two things in mind. Whenever we want an under data, we will have to shade less than portion, and whenever we have over data, we will have to shade for greater than portion. Now our data is going to be below. Below stands for, below also represents under. Therefore, we'll have to go for less than portion or the lower portion. So starting from 0, measure 6%, which is very small area, 0.06. So let me draw it over here. So this is going to be 6%, and since we have under, I am going to shade the lower portion of it. Which portion? Lower portion of it. So this is going to be my under portion, and this is going to be my 6%. Now I know that the value of x at this position, this has been given to me as x equal to 60. What is my target? I need to find what is z in this corresponding position. Now how to estimate this value? The entire of the area is 100, and what we know about half area, this half area is going to be equal to 50% of the data. From this half area, the table which has been given to me, normal distribution, can measure from the center to any particular line. Now in which case, from center to this particular line, how much is the data available to me from the center to this particular line? If I am able to find this area, and this area is going to give me the corresponding z, and if z is known, then I can fix the remaining data for me. Okay, so this is my from the center of the table to any particular position. What is the position now? X equal to 60 is going to be the position. Now how much is this yellow color portion contributing to? What is the area? So it is going to be 50 minus 6. 50 minus 6 contributes to 44% of area. So this yellow portion is 44%. From center to this line, this is going to be 44%. In terms of decimals, it is going to be 0.44. So now I need to search for 0.44. Where is going to be my 0.44 occurring for the first time? So where it is occurring? Here, 0.39, and here comes my 0.44. So 0.44 occurs for the first time with 1.5 in my z in the first position, and for the decimal position it is going to be 6. So what is the value of z? 0.44 area corresponds to z is equal to 1.56. Now once the value of z has been got, what is the next question we need to ask ourselves? Is z positive in this region, or z is going to be negative in this region? This is from minus infinity to plus infinity, and we are seeking the left hand side portion. So left hand side means z will be positive or negative, children? Yes, you're right. Z is going to be negative in this region. So I have minus 1.56. Let me fix it with the given data. Z is equal to, I know the standard formula is x minus mu divided by sigma. On fixing it, minus 1.56 times is equal to 60 minus mu divided by sigma, or minus 1.56 times of sigma equal to 60 minus mu. Mark this as equation number 1. Now let us go for the second data which has been given to us. The second data says 39% of the students have height between 60 to 70 inches. So the keyword over here is going to be between. So already the 60 line has been marked. So starting from 60 to 70, how much of the percentage has to be covered? I need to cover 39% of data. So starting from this line, which is x equal to 60, I need to cover 39%. If I cover 39%, what will happen? I will have the line x equal to 70. But the quantity we need to think is that whether this line x equal to 70 will lie to the left hand side of the data or out to the right hand side. Okay, so we will check about it. How much has been covered over here? Here we are covered 6%. Starting from 60, how much I need to cover next? I need to cover next 39%. So 6% plus 39%. How much will this both contribute to? Together they will give me 45%. So is 45% less than 50 or greater than 50? Yes, you are right. It is less than 50. Therefore, the line x equal to 70 will lie to the left hand side of my data. And so it will not cross the boundary and go. It will be over here. Now let me measure from the center. How much percentage I want? I want 39%. If I am going to measure 39%, then I can draw this line called as x equal to 70. So I want the line x equal to 70. How will this line x equal to 70 look like? So this is going to be my line x equal to 70. So x equal to 70. Now what is the second thing I need to find? I need to find what is z at this position. What is z at this position? So to estimate z at this position, what I need to know, from the center, this x equal to 70, how much portion is it contributing to, or how much portion does it occupy? Now let us find this data using the given graph. So from the center, I want this portion which is going to be the line x equal to 70. How to estimate it? The total half area is going to be equal to how much? 50%. Out of the 50, how much has gone now? 6 has gone over here and 39 has gone over here. So what will be 6 plus 39? So it is going to be 45. Totally it is 50. So I have 45% which has been covered from over here to here. So this is going to be 6 plus 39, 45%. So what do you think that this portion will be now equal to? Yes, you are right. 50 minus 45. This will contribute 5% of my data. So we will draw this data very clearly in our next slide. So I have the normal distribution curve. The second data is going to be from x equal to 62. The straight line, we will mark it over here. This is going to be the straight line. So this is going to be my 70 line, and this is going to be my x equal to 60 line. Okay, so I have the values to be equal to, this is going to be my x equal to 60 and this is going to be x equal to 70. Between 60 to 70, how much of the portion I have covered for? I have covered for 39% of the data, and this has gone for 6% of the data. So how much will be left out over here? 6 plus 39 makes it as 45%. 6 and 39 makes it as 45%. Total half the area is going to be equal to 50%. So how much will be this left out portion for me? This left out portion for me will now be equal to, So this left out portion for me will be equal to 50 minus 45. What will be 50 minus 45? 50 minus 45 will be equal to 5%. So now this represent 5% of the data. What is 5% in terms of decimal? 0.05. So I need what is Z in this position. From the center I have measured 5%. So what is Z in this position for me? Now go search your table over here for 0.05. Where is 0.05 happening or occurring for the first time? 0.05. Here it is happening for the first time. And what do you think is the value of Z corresponding to it? The value of Z is going to be equal to 0.1, and on top it is the second decimal is going to be equal to 3. So Z is going to be 0.13. And after getting the value for Z equal to 0.13 corresponding to the area 0.05, the next question we need to ask ourselves is going to be, Z is going to be positive or is it negative in this region? What do you think about this? This is our 50% mark, and this is going to be from minus infinity to plus infinity. Our Z lies to the left hand side of the data. So left hand side means Z is positive or negative? Yes, you are right. Z is negative. So fixing it in the standard formula, Z is equal to x minus mu divided by sigma. I know Z is equal to minus 0.13, which is equal to, what is x in this position? 70 minus mu divided by sigma. So on cross multiplying, minus 0.13 sigma equal to 70 minus mu. Mark this as equation number 2. Over here we have equation number 1, which is given by minus 1.56 sigma equal to 16 minus mu. What is the second data given to us? The second data given to us is minus 0.13 sigma equal to 70 minus mu. What is our target next? Our target next is to solve these two equations. Minus 1.56 sigma equal to 60 minus mu. The second data is minus 0.13 sigma equal to 70 minus mu. I can subtract to cancel off this mu. Subtracting will change the sign. So this will become positive, negative, positive. So this will cancel off to give you 1.43 sigma equal to 10. So this sigma gives us 10 by 1.43. So sigma is equal to 6.993. Once the value of sigma has been got, you can resubstitute it back in any one of these equations. So say suppose I have the first equation, minus 1.56 sigma equal to 60 minus mu. I want what is this mu over here. So minus 1.56 sigma, now we have got it over here. Substitute 6.993 equal to 60 minus mu. Take your mu to the opposite side. So this becomes 60 minus, if you take it to the opposite side, 60 minus of this quantity will become plus 1.56 into 6.993. So you will have the value of mu to be estimated as 70.909. So check if you are able to get it all by your own using the calculators. Thank you.